Hello everyone. So today in this video we are mainly going to study about the different types of logic gate, and at the end of this video we will see some numericals which are very common in your JEE and NEET, both from logic gate and other type of semiconductor questions also, that has the potential chance to come in your next JEE or NEET exam. Now first let us understand what do you mean by logic gate. See, logic gates are basic, or you can say fundamental electronic circuit that performs basic logical operations, and it is totally based on binary input, binary function. What do you mean by binary? Only 0 and 1. Okay, that means it works only on 0 and 1. Like you can say a simple switch at your room. Okay, if fan switch or a light switch, if you see a fan switch or a light switch, you will see that there are small markings of 1 and 0, where 1 means high or on and 0 means low or off. Okay, so logic gates are basic electronic components which works on binary input. Okay, now you can see that here we are having three types of logic gate which are your basic logic gate, and below we are having two more logic gate which are your combinational logic gate. That means ये जो ऊपर का जो तीन लॉजिक गेट है इसको कंबाइन करके हम लोग को फिर कॉम्बिनेशनल लॉजिक गेट मिलता है. ओके, सो फर्स्ट लेट अस सी दैट व्हाट इज द बेसिक टाइप ऑफ लॉजिक गेट. सो यू कैन सी दैट द फर्स्ट लॉजिक गेट वी हैव हियर इज योर OR gate. Now it has two input, it might have more than two input also. Okay, so it will have two or more input and it will give one output. Now what is the main function of an OR gate? It is called OR gate, OR. Okay, so the main function of an OR gate is to perform addition. The main function of an OR gate is to perform addition. So it will take binary input and by combining them it will give output. Okay, and it will perform the function of addition. So you can see here that we are having two input A and B and one output. The first, since binary number, so the first combination may be 0 0 0 plus 0, it will give you 0. That means low output. Okay, similarly 0 plus 1 you will get 1, that means high. Again 1 plus 0 you will get 1, 1 plus 1 you will get 1. Again be specific that we don't have here 1 plus 1 means 2, because it's binary number. It will either give you 0 or 1. So 1 plus 1 means high plus high, so you will get the output as high only. Okay, the second type of logic gate is your AND gate. So again AND gate, you can see it looks something like the structure of D. Okay, again it can have two or more than two input, it will give you one output, and the main function of this gate is to perform multiplication. That means it behaves like a multiplier. So you will have first combination 0 into 0 you will get 0, 0 into 1 you will get 0, 1 into 0 you will get 0, 1 into 1 you will get 1. That means only when both the input are high you will get the output high, and remaining all the three output will be low. Okay, now the third basic type of logic gate that you have is a NOT gate. Okay, so NOT gate, you can see that it has a triangle type structure here, and here there will be a small circle. Okay, it is based on single input. It will take a single input and it will give a single output. A NOT gate is also called inverter. Okay, a NOT gate is also called an inverter gate. Why? Because whatever input it will take, it will just invert and give the output. So when the input will be low, 0, the output will be high, 1. Similarly, when the input will be low, 1, the output will be, when the input will be high, 1, the output will be low, 0. So ये सिर्फ उल्टा कर देगा. Okay, it will just invert the input. Okay, now based on the above three basic logic gate, we have combinational logic gate. So you can see here the first logic gate is combinational logic gate is your NOR gate. So what is NOR gate? This is your OR gate. Okay, and NOT gate कैसा था? A triangle with a circle. वो NOT gate का circle यहाँ पे आ गया. So this becomes your NOR gate. So you can say what is a NOR gate? Okay, it is NOT gate plus OR gate. Combination of NOT gate plus OR gate is your NOR gate. Now what was the function of NOT gate? The function of NOT gate was to invert. And what was the function of OR gate? The function of OR gate was to add. So now there will be addition, and then there will be inversion. Okay, that means first whatever input will be there, it will be added up and then it will get inverted. Okay, so we are having two input here, A and B, and one single output. So you can see first if we take 0 plus 0, so see addition then invert. So 0 plus 0 will be 0, invert 1. 0 plus 1 will be 1, invert 0. 1 plus 0 will be 1, invert 0. 1 plus 1 will be 1, invert 0. Okay, so what is NOR gate? Combination of OR gate plus NOT gate. So it will do addition and then it will invert the answer. Okay. Similarly, next you have NAND gate. So what is a NAND gate? A NAND gate is a combination of AND gate plus OR gate. So AND gate, it looks something like this structure D, and NOT gate circle will come here. So this is your NAND gate. What was the function of AND gate? To multiply. And what was the function of OR gate? Okay, what was the I said, not OR, it will be AND plus NOT gate. Okay, it will be AND plus NOT gate, so it will become NAND gate. So what was the function of AND gate? The function of AND gate was to multiply. And what was the function of NOT gate? The function of NOT gate was to invert. So first there will be multiplication and then there will be inversion. Okay, so 0 into 0, 0, inversion 1. 0 into 1, 0, inversion 1. 1 into 0, 0, inversion 1. 1 into 1, 1, inversion 0. Okay, so this is how you actually see how to, check out the truth table or output of the different logic gate. So you remember that what are the most basic type of logic gate? OR gate, which performs addition. Then you have AND gate, which performs multiplication. Then you have NOT gate, which will just invert the input. Now, based on the above three, you are having combination. First combination, you have NOR gate, which is a combination of NOT plus OR. So it will first add, then invert, and then you are having NAND gate, which is a combination of AND plus NOT. So first it will do multiplication and then it will invert the final output. Okay. Okay, so based on the concept of logic gate, okay, let us see some questions which will clear your concept a little bit further. Now, see the first question. The first question here, this one, is given that which logic gate is represented by the following combination of gate. So here you are having a combinational circuit, and based on the combinational circuit, you have to find the truth table. पहले क्या करोगे? You will write down the truth table. Okay. After writing the table, you have to compare that ये जो table हम लोग को output पे मिला, it resemble. Okay, which one? OR gate, NAND gate, AND gate, or NOT gate? You have to select the correct option. Now you can see that we are having two input here, A and B. So we have written down the two input A, B, and we are having one output Y. So we have also written down the output here Y. Now you can see that first you are having here a NOT gate. NOT gate क्या करेगा? Invert. This is also a NOT gate. ये भी क्या करेगा? Invert. And then here you are having a combinational gate. So you can see that this is a NOR gate. Yes or no? This is OR plus NOT. So it will first do addition and then it will do inversion. Yes or no? NOR gate का काम क्या था? पहले सबसे पहले वो ऐड करेगा, फिर ऐड करके जो फाइनल जो मिलेगा उसको फिर से वो इन्वर्ट कर देगा. Yes or no? Addition plus inversion. NOR gate. So now let us see. First we will take combination of 0, 0. That means A0, B0. Okay, this 0 will go from here, NOT gate, and it will invert, and here you will receive what? 1. Similarly, this 0 will go from here and it will get inverted, and here you will receive how much? You will receive here also 1. Now, first it will get added up, so 1 plus 1, 1, and then it will get inverted, so it will become 0. So you will get here 0. Okay. Let us take the next combination. Next combination, let us say we are taking 0, 1. So now this one will become 1. When you will take 0, here you will get 1 only. When you will take 1, it will get inverted, and here you will get 0. Okay. Now addition 1 plus 0 will be 1. Inverted, you will get how much? You will get 0 only. Okay. Then we can take 1, 0. So now this one will become 1 and this one will become 0. When you take this one 1, this one will become here 0 inverted, and this 0 will get inverted and will become 1 here. Now 0 plus 1, you will get 1 and inverted. So you will again get 0. Finally, you can take 1, 1. This one will get inverted, become 0 here. Inverted becomes 0 here. 0 plus 0, 0. Inverted, you will get 1. So 1, 1, you will get 1. So this one will be your final truth table. Now, you have to check. We have some kind of logic gates. So you have to check that this logic gate table, that is a truth table that we got here, it resembles which one? So as we know that this truth table where we are getting 0, 0, 0 and output is only high when both the input is high is nothing but your AND gate. So your correct answer here will be AND gate. Okay, I hope it is clear. You have to compare this truth table with all the given options and you have to match them. Okay, so if you compare this truth table, you can say that this truth table is of which one? Nothing but AND gate. Okay, now let us come to the next one. That means second question, this one. Okay, so here also we are having two input A and B, one output, and we are having certain combinational gate and we have to select the correct truth table. So I will just make the truth table roughly here, A, B and output Y. Okay, so you can see the combination. First combination is 0, 0. This is what? This is NOT gate, so it will invert. This is what? This is NAND gate, so it will first multiply and then invert. NOT gate क्या था? Add plus invert. NAND gate क्या होगा? Multiply then invert. Yes or no? Okay, so if you take 0, 0, first 0, 0. So if you take 0, 0, this 0 will become 1 here, this 0 will become 1 here. Then 1 into 1, multiply 1 and 0. So you will get 0, 0. Okay, inverted, you will get 0. Okay, then again, if we take the next combination, this is 0, now this is 1. So this one will become inverted 1 here and this 1 will become inverted 0 here. Now 1 into 0, if you multiply, you will get 0, inverted, you will get 1. So if you take 0, 1, you will get 1. Okay, if you take 1, 0, so if you take 1, 0, so now this is 1, this is 0. So it will become invert, it will become 0 here and this one will get inverted and it will become 1 here. Now 1 into 0, you will get 0, inverted, you will get 1. Okay, the last one, final one, 1, 1. If I take both 1, so now this is also 1 and this is also 1. So it will become inverted here 0, this one will also become inverted here 0. 0 into 0, 0, inverted 1. So when we take 1, 1, we will again 1. So what will be our final output? 0, 1, 1, 1. You can see the option, that option 1 is correct here. So your answer will be option A. Okay, similarly move on to the next question. That means this one, question number 24 marked and is, which is marked as 24 here. So again, we will make one rough output. A, B, Y for the truth table and we will check the answer. Okay, now this is a little bit more complicated the previous one, so please try to understand properly. You can see that this question is from NCERT as well as it came in NEET 2022. The previous question was also in NCERT and NEET 2023. Okay, so first we will take the combination. The combination are like this only, na? 0, 0, then you have 0, 1, then you have 1, 0 and finally we will have 1, 1. Yes or no? Now you can see that this is what? This is a NOT gate. This is what? This is your NAND gate. So it will do what? It will multiply, invert, multiply, invert, multiply, invert. Okay, so we have to be a little bit more specific here, okay, while doing the calculation. So now you see the first one. When I take 0, 0, okay, so 0, 0, what will happen? Now you can see that A is connected in two ways. Yes or no? Similarly, B is also connected in two ways. Please try to understand. I will just zoom in a little bit, okay? So this 0 will directly go here. So here also you will get 0, okay? And this 0 will again come from here. It will pass through the inverter gate and here you will receive an opposite. So you will receive 1 here. Now similarly, okay, you are taking B as 0. So B will directly go from here 0. But B is also connected here. So B will go from here to here directly and it will go 0. Okay, because we don't have any inverter here. So it will remain as it is. Understood? A 0, directly A will go here 0. Then A will come here, get inverted and A will come here to be as 1. Now, here it will get multiply, so 0 into 0 multiply, you will receive here, and then it will get inverted, so it will become 1, so you will receive here 1. Similarly 1 into 0, you will get how much? 0, it will get inverted and you will receive 1 here. Then finally 1 into 1 will be what? Okay, this is not a NAND gate, na? It is only an AND gate, so there will be only multiplication, sorry. There will be only multiplication, no multiplication and inversion, okay? There will be only multiplication here. So 1 into 1, you will get output as 1, okay? So for the first one, 0, 0, you will get how much? You will get 1 here, okay? Similarly, if you take 0 and 1, okay? 1, 0 and 1 and 1. So I hope you have understood the first one. Let us see the second one. The remaining two you can try yourself, okay? So 0 and 1. If we take this one as 0 and 1. So here you are having 0 and here you are having 1, okay? So this 0 will pass on here. Here you will get 0. This 1 through B will pass on and here you will get 1, okay? Now this 0 will again go inverted here and it will come here as 1. Again, we are taking 0 and 1. So this 1 will go here. Here also you will get 1. So now here you are having 0 into 1. So you will get 0 inverted 1. Here also you are having, I guess, B was how much? B was 1 only. So you are here you are having 1 into 1. So it will become 1 inverted 0. So you will get 0 here. Now finally multiplied 1 into 0. So you will get 0 for the second one. So for the second one you will get here 0. Okay, similarly check the other two and find that which should be the correct option. I hope you have understood up to this much. Okay. Okay, so let us just see some numericals here. Okay, so you can see that I have put on some basics questions, and most of the type of question that comes in JEE, NEET, okay, are simple calculation or truth table based, or you will get this kind of question. Okay, so let us see the first question, that is question number 74. So in question number 74, you can see that it is given then in which of the following, in the given figure, which of the diodes are forward biased. Now this is the structure, or you can say symbol of a PN junction diode, where this triangle means P and this bar means N. Okay, now PN junction diode can be either forward or reverse. Forward bias means P should be at high potential and N should be at low potential. Okay, you just reverse this one. If you reverse, if P is at low potential and N is at high potential, that is called reverse bias. Okay, so when P is at higher potential, N is at lower potential, forward biased. When P is at lower potential, N at higher potential, reverse biased. During forward biased, a diode allows current to pass, and during reverse biased, a diode will block the current and it will not allow to pass through it. Okay, so see the first structure. So you can see that this is your P and this is your N. So P is connected to ground, that means 0, and N is connected to 5. So here P is at lower potential, so this cannot be forward biased. The second one, here P is at 10 volt and N is at 5 volt. So P is obviously connected at higher and N is at lower. So this is forward biased. The third one, P is connected as -5, okay, and N is connected at 0 volt. So you can see N is at higher potential, P is at lower potential. So this cannot be forward biased. In the second one, okay, P is at -5, N is at -12. So obviously P is higher potential and lower potential. So P, the fourth one is your forward biased. The last one, okay, P is grounded, so 0 volt, and N is connected to -10. So P is at higher, N is at lower. So this is also forward bias. So which are the forward bias diode here? 2, 4 and 5. So we'll get 2, 4 and 5. That is option B. Okay. Now see the next question number 76. Consider the following given figure. Suppose the potential difference between A and B is V. Find the potential difference between A and B. That means you have to find the value of V here. Now you can see we are having a forward potential of 0.3 here. We will just apply Ohm's law to find V. Okay, so V, if I apply V equal to IR here. So we will take the potential difference between A and B. We are already having a potential of 0.3 volt and we will take the net potential to be V here. So we can write V minus 0.3 equals to I. I is your current. Current is your 0.2 milliampere. So it will become 0.2 into 10 to the power minus 3. Okay. And resistance, you can see that R1 and R2 are connected in series. So this one will become 5 plus 5, 10 kilo ohm. So it will be 10 into 10 to the power 3 ohm. Okay, you solve this one. If you solve this one, you will get V equal to 2.3 volt. That is the unknown value that you need to find here. Okay, move on to the next question number here. See, this type of questions are very common. Okay, so here you are having a higher potential 6 volt and a lower potential, this one is grounded, so this one will be 0 volt, and you are having a LED bulb. Now there are A and B which you can take as binary input. That means you can take the combination of 0 1 0 0 1 0 1 1, and you have to see that if the output is 1 or not. If the output is 1, then the LED will glow. If the output is not 1, the LED will not glow. Okay, now how to check this one? See, if I here 1 means it's a closed path, 0 means it's an open path. Okay, so if I take both to be 0, that means this is 0, this is 0. If I take this to be 0, that means this path is open. Then current will not flow through here. Current will directly go from here to here, and when current will flow from here to here, obviously the bulb will glow. Okay, because the current bulb is receiving the current. So when you will get 0 0, it will be what? 1. Why? Because the bulb will glow. Now if you take 0 1, let us say we are taking this one 0 and we are taking this one as 1. See, when you take 0 1, current will flow from higher potential. Since this path is open, so current will not flow through here, so current will directly flow through here. So again the LED will receive current, so it will glow. So here again you will get 1. If you take 1 0, same 1 0, this path will be open, so there will be no current flow, so current will directly flow from this side, so again it will glow. Last, if you take 1 1, if you take 1 1, this is also a closed path, this is also a closed path, so current will come from here, it will go from here, again here, again here, and then it will directly go to the ground. So this current will not reach to the LED. As a result, it will not glow, so it will be 0. Okay, so the output you will get 1 1 1 0. So we know that 1 1 1 0 is nothing but the truth table of NAND gate. So your answer will be NAND gate. Okay, I hope up to this much you have understood. You can practice similar type of questions, okay, from semiconductor devices. Also practice logic gate question. Chances are there that there might be 1 or 2 question. One is for sure. There might be sometimes 2 question also from logic gate portion. Okay, thank you.